This is the Eggstronaut challenge, and we are Team Space Egg X. I'm Desiree Jonas.
And Zach. And prevent a large-sized egg from cracking. It being able to achieve the goal, surviving at even higher. We want to be able to use the engineering statics that we learned during the class and use it in a real-life situation, and in this case, our project.
So CO2 cartridges, plastic bags, and string. We had to drop it from 1 meter, that was the minimum drop, and the maximum weight had to be 450 grams. The landing had to be about 300 millimeters by 300 millimeters, and the glue can only be put on joints and not along any of the members. And we couldn't paint it or anything like the structure. The eggs could be decorated though, and only four CO2 canisters could be used.
Now, for brainstorming, when we first really didn't know exactly where we were going with our brainstorming and stuff. We wanted to make sure everyone in our group understood what exactly the project requirements were, the design requirements, how big we could make our project, what kind of pastas we could use. We wanted to understand what other pastas we could use, because in the design requirements it says any pastas. More specifically, it says spaghetti. And when we realized that we could use any pasta, we started thinking of other pastas aside from spaghetti. We were thinking of macaroni, ravioli, rigatoni, and all the other kinds of pastas. And when we were thinking about that, we wanted to discuss about the durability and involving the specific pastas that we could use for our project. And in the end, we ended up just keeping with spaghetti.
So as our brainstorming continued, we thought about making legs for our lander. So you see in our first design, you can see in the picture how it had 4 legs, and they're made out of triangular structures. And we looked at real space landers online, so that's kind of like how we got the idea. And then we just on top and triangles on the bottom as legs.
Now, we were using both the designs that were shown earlier, and we wanted to our first design. We wanted to make the first drawing that was on the left earlier. We wanted to make it and use those first 2 designs as a way to work out in the future as well. But with this first design, we just felt like we wanted to cage the egg in with this one, with our first design. And we just felt, because if we cage the egg in, then it'll be able to stay safe and it won't really be able to break. And we also made legs from at the bottom as well, and
So then we decided to have 2 designs. So we were just grasping the idea of the first design, seeing how it was going, and then we also had another design that included like a hexagon shape at the bottom, and it had that thicker pasta to act as supports on the bottom of that. So we built both of them, and then we got to see how they came out.
For design 1, we really were on a more organized side versus design 2, but the way we were interpreting both designs was completely different. Design 1 is a design that we actually looked forward to using in the future and possibly being our final design in this project at the time. Design 1, we had a cube-like structure and pyramid-like structures at the bottom, and we had the egg in the center being a cage for that, which is like the cube-like structure. We felt that having the egg all condensed like that, it would be a safe thing. And also, although the pictures do not give it justice, the design 1 structure, it's very small, and we felt that we didn't really need like a big, like bulky or large kind of design, that just as long as it could hold and maintain the forest when falling, then it would be fine. We didn't really need a strong and bulky thing. Now for design 2, if you notice, it's not really that neat or organized as design 1 is. Design 2, what we wanted to do for design 2 is we really wanted to learn from this design or prototype, that to see what we were dealing with, to fully understand how strong our spaghetti was, if we could use excuse me, if we could use a different kind of spaghetti, what really it was going to take to keep the egg and the lander safe when dropping it. And we really wanted to use design 2 as a way to know exactly what we're dealing with in this product versus design 1, which is the kind of the opposite of that. And and yes, and here's a video of us testing design 1.
Go.
So after testing both designs, we saw that they both had pretty good ideas, but we saw when we tested the first design with the egg that the cube was not good enough to keep the egg inside and it would cause it to be unstable. And we also saw that while the triangles were strong, it broke in the middle of the supports. So it didn't break completely, but it wasn't as strong as we needed it to be. Although they were both very good designs, we decided to come up with an entire new design. And we also thought that as part of our engineering process, just that we can get some outside influence, and we did this outside influence using Avenger chassis. They build sprint cars here in El Paso, Texas, and they have a strong design for their cars. So we just thought talking to them, talking to the design engineer from UNT, it would just give us some more background information. We just wanted to go as far as we could to have the best performing lander. So what we finally decided was that triangles were going to be our strongest bet, equilateral triangles at that. So we decided to go forward with a pyramid, and our pyramid would have 10 by 10 centimeter equilateral triangles, and then inside that equilateral triangle would be 5 centimeters, and inside that equilateral triangle would be another equilateral triangle of 2.5 centimeters. So we decided to go through this pyramid, and as you can see, our mistake in the first design of our final design was that we made individual pyramids that we thought we were just going to kind of like stack on top of each other and then glue them at the supports. But obviously, and we also made individual triangles to make those pyramids. So they were not sharing faces, they were not sharing sides, and it made it very difficult for them to fit because they were taking up space. But we decided to just test this while we had it, and this is a video of us testing the first design of our final design.
Like that was broken, I just like glued it back together.
But the egg is fine.
So that was our first video with our first design of the final design. So what we decided to change with that design was obviously to build it from the ground up. So we were just it was gonna be difficult and it was gonna take a long time. In fact, it took 8 hours, but we were just gonna build it from the ground up. We had the 10 centimeters, we just were gluing, and eventually we made this pyramid. And we put the egg inside of there, and as you can see, there has supports going all along. They're sharing all the sides. It's a perfect pyramid. I mean, of course, some sides are not as equal as they should be, but this pyramid is a pretty good design, and we also see that it weighs about 118 grams, and we were pretty surprised with this weight because that is including the egg. It weighs 118 grams. So, and we noticed that this is actually a pretty strong design. Even by pressing on it, we could tell that was a pretty strong design. They could withstand a lot of force, but I mean, we couldn't just do that without doing the calculations. So we did the calculations, and there's some misinformation here. It's supposed to be 21 centimeters and 60 degrees because equilateral triangles have 60-degree angles. So the way the egg was 59 kilonewtons, the force resultant was 83 kilonewtons. The force with the mass times acceleration was 1.166 newtons, and then the potential energy 1.166 joules along with the kinetic energy. And then we also calculated velocity, and you can see how we were using all these equations that we learned in statics along with the equations that we will learn next semester in dynamics. This is just another slide just talking about the velocity and how we calculated it. And we were pretty confident that it was letting us know that we were going to be able to withstand enough force. But not only could we do this with calculations, we wanted to do a simulation. So when we did the simulation, we did it with the provided network, and As you can see, we had the zero trust members that it was telling us that there were some zero trust members, and then we also see that we added the force resultant that was gonna on one side of the pyramid because he said to do one leg. I wasn't able to take a video of the simulation, but when we did it, we calculated that at 1 meter it would survive the fall, and the simulation actually proved that. And it was really awesome to see this on a computer, and not only by testing yourself, but you can just make it on the computer and see if it's gonna work.
And although it's not really contributing as much to our PowerPoint, but we just felt that our egg designs, we wanted to put them on. Just we felt proud about what we did with our egg designs, being with the NASA logo on one side of the egg, and then the alien face on the other side of the egg. And we wrote down a little joke on the side next to the alien. You could read it right there.
We know Dr. Stewart's a fan of jokes.
And we found it to be we just enjoyed painting the part and designing the egg as well. And for our final performance, before we speak on it, we want to show 2 videos of our final performance, of course, and then speak on it. For these two videos, the first video is on it's the 1 meter drop, and then the next video will be the 2nd meter drop.
Okay, so as you can see, our 1 meter drop was completely successful. In fact, our truss system did not even break at all. The egg survived, our structure survived. It was quite awesome. And then from the 2nd meter drop, the same thing happened. Our egg survived, and we saw some breaks on one edge of the pyramid, but it was very strong. It survived, and we also we're pretty proud of our design because we had the design that weighed the least amount.
Mm-hmm. And with it weighing the least amount, that would lead us to getting 2nd place in the performance for the entire class, and we were real proud of that. And also to conclude our PowerPoint, with learning with the statics that we learned from the class and putting it into this performance and this project, we learned that yes, indeed, that we got 2nd place, and we did well, and we gave it a well enough lander. We learned from our performance that we should have moved because from the pictures in the past, we should have moved our egg. Let me go back real quick. We should have you see how our egg is at the top? We should have moved our egg to the dead center of our pyramid to make sure to not have weight, like, so we can't have our lander tilting on one end because more weight is on that end. And with all we've learned, we noticed that if we would have put it in the dead center, then we would get the same result from any side that it would have fell on, regardless of how it was falling and etc. And we felt like that would be true because we did not show a video of the last part, but we dropped our egg or our lander from a very high bridge that was near the area, and the egg popped and everything. But if we knew that our lander was still in well enough shape after being dropped from that bridge, and we knew if we put our egg in the dead center, it would have been better. But
because the weight caused the egg to be the first thing that fell, so the whole design flipped over and it landed face first on the egg. But if we would have had in the middle, it would have just stayed going in one direction, and either way, whichever direction it fell, there would have been equal protection all around the egg. So that would have made all of the drops, and even from the bridge, it did not break that much. So we noticed that using triangles and from using all the information that we learned in statics, that we could create a good enough structure to withstand a 1 meter drop. And we were pretty proud to get 2nd place and to put all this work into it. I mean, it took 8 hours to build that thing, and we had to do it another time because that was just our prototype. So many different designs, and then deciding our final design. It was a great engineering project with great learning.
And yes.
And we'd just like to thank you for watching.
Yes, and thank you for watching. This is our PowerPoint. Thank you.